Hello everyone, thank you for coming along to the Test Automation in the Networking World presentation today. We're currently coming to you from stage 4 COVID-19 lockdowns in Melbourne, Australia. It would have been nice to be able to deliver this to you all in person, face to face, but we deal with issues very different for everyone, so hopefully we can still provide you with some useful information that you can take away from today. So let's get into it. First things first, quick introduction. My name is Nick Keating. My co-presenter today is Sherriff. We are both network engineers at Telstra, based out of Melbourne in Australia. A little background on what we do. We both work in a testing services, dedicated testing services business unit within Telstra that focuses on testing networking topologies and networking protocols for a range of engineering groups and a range of different networks within Telstra. That testing has historically been done manually by our group, but there's been a shift towards automating this testing over the last sort of 3 years, and that's where our automation journey has begun. And so with that, a little bit of a disclaimer, we're still relatively new to this whole automation thing ourselves. Like I say, 3 years ago when we started it, we were very new. And so we're not speaking by any means as experts here today, but just wanted to come from a position of our own experience, our own learning, and just try and convey some of that and some of the challenges that we faced along the way. So with that, I'll hand you over to Chi to talk about why we're here to present to you today.
Thank you, Nick. Yes, as mentioned, both Nick and myself, we come from network engineering, part of test engineering area in our business. Testing has been an important part for our business, network delivery and product delivery. And most of the testing we do actually are network interoperating system for our vendor and our platforms for different platforms for Telstra. So in the topology that we use, our test topology, often range between 15 to 20 devices across our infrastructure network in the lab, which is a representation of our production network, and it is across over multi-vendors and platforms. So to build an environment for this for testing, it is time consuming, and it also, if we change topology, which often we do, it's repeated, and some of the test activities are repetitive. So at the time I wanted to find a way to automate all of this, and firstly to make our life easier, and most of all we want to repeat and reuse all of the information that we build. So in that, the goal was that for us to build the environment, test it, log the result, and report it. So that has been the automation goal from the beginning. Then we, as a network engineer, to look at building something like this from scratch to automate such a goal certainly is not my first option. So I went and looked for everything that would help us to do that as a tool in open community or proprietary, but there was none in 2017 that looked after such a goal we wanted to do for multi-vendor. So I went on and plan B, trying to look for guidance as to how we build this, but I found a great repository that for configuration management and connection to devices. But when it comes to getting the device data, operational data, a tool to do that, the resources restricted and also limited. So today, Nick and I are hoping to share some of our experience and some of the principles that we came to understand while we built the automation tool we have today. So to you, Nick.
Thanks, Chi. So yeah, just a little bit of a quick outline of today's presentation. So once, as Chi mentioned, once we decided to actually go alone here and build our test automation framework from scratch, there was a range of design goals that we sort of had to try and aim to meet, and some questions that we had to ask ourselves, and what do we want from this thing? So first and foremost, the idea, the overall goal of this is how do we lower the cost and shorten the time of a network testing program, but without jeopardising the test quality whatsoever. So that's the main goal. But then following on from that, there's a lot of other questions that are more specific for the environment itself. So for the lab, as Chi mentioned, the lab that we work in is a very large scale. It's actually considered a medium-sized ISP in and of itself. And it services many networks, many vendors, all different types of testing. So how does a framework address all of this variety? And then once that variety is also there, how do you make the code that you develop in a test automation framework actually reusable and be able to cover all of that variety? As such, our team here also delivers a lot of manual testing still currently to this day. So a framework that gets built and implemented in this environment needs to be able to coexist in an environment that's both manual and automation testing. They're sharing the same devices, sharing the same network equipment. So that's a very big challenge for us to try and answer. Another thing was that we don't want to just automate the actual execution phase of the test program. There's a whole range of other things that surround that we'll expand on a little bit later, but we want to automate the entire workflow as opposed to just the execution phase. And then on top of that, we need to be able to accommodate the nature of test topologies that are changing quite regularly and quite quickly. So as a bit of an outline of today's presentation, basically what we're going to go through is there's some very generic principles that most people that are in the network automation area sort of know and understand in some way, but what we wanted to try and do is, what we found is it's actually quite a very different implementation to implementing these principles in the network testing space as opposed to actually in the network operational space. So what we tried to do today is just talk a little bit about those differences and how we've had to actually implement them slightly differently in the network testing space to then actually address, and how that's then helped us address these design goals and actually answer a lot of the questions. So that's a bit of the outline of the talk today, and what I'll do is hand you back to Chi to talk about the first of these principles, which is our inventory.
Thank you, Nick. This is the inventory first principle. Before I go into inventory, just want to draw some of the differences in inventory and in the environment between lab and production. The production environment really has all of the approved version of what we tested in the lab, and also the final target, where the lab is that and things that haven't been approved, and also involving that means different versions of things, and also hardware that is not yet in the lab. So what is our inventory? It is a database that consists of information that we collect from each device in the network that is in scope for automation. And the information we get are from the XML agent of each device and store them in our database. Now this information for each device is presented as structured data for all our user, and also presented as a unified, uniform structure in presentation, so that allow us to query any of this information in the same way, regardless of vendor or platforms. So that inventory, in order to capture the rapid changes in the lab, it is currently updated. We cannot set and forget, so it's updated every hour in our lab, and in the future, perhaps we will try to get the network device to trigger the update, as long as it doesn't, for the events that are not part of testing. So that, because changing hardware could be part of the testing as well. So that is our inventory, and the inventory is actually the backbone. It provides the structure for all of our build for the automation from here on. So the structure for the inventory is used for almost everything that we build. So then what is our source of truth? Is it our source of truth? Well, it is the backbone, but our source of truth actually lays with the test case, because the test topology varies between the test cases. So we build the source of truth for every test case. So every test case, the source of truth is built from the structure of the inventory. So when we talk about test case, most of us think about this execution phase of the test case, that block. But in fact, it is an entire workflow that is like from the beginning to the end, and that is a test case. This is how we manually test, and so we automate the same workflow. So from the left, the test topology. So start off, we build and select and also validate our test topology from the inventory, and the structure of the inventory will be used to build our source of truth for our test case. So then this is an instance of the inventory that is being presented for the test case as structured data. From here, we then add the user input. So some test cases we don't have user input, but most we do. So for the user input, it doesn't have to be a lot, just the beginning, some VLANs and IP structure. Then it goes through the process and we update this instance of the inventory with all the information enough to configure the entire topology all the way to the end, which is perhaps the CPE or anything representing CPE, such as maybe AXIA, traffic generator. So that is updated with this instance of the inventory. Then next we go to checkout, making sure that everything comes up. This is an important part of our test case, mainly because it holds all the information that the same source that's going to be used and in the same structure as the inventory to be used in all the coming on to from configuration to execution. All the functions called in the execution phase also refer to all this source. To the point where we remove the configuration and release the all the way to when we release the resource. So that is our source of truth for the test case. And so this is where we have the consistency of this source of truth allow us to build the reusability for most of the structure that comes after. So I'll hand over to Nick to talk about the next principle, which is modularity.
Thank you, Chi. So yeah, the next principle we wanted to touch on is modularity. So modularity for us was basically the key to reusability and answering the design questions that we had around how do we reuse all of this code that we build. And the main design decision that allowed that to happen was we chose to focus on actually, instead of creating test cases and writing code that is a specific test case related, what we decided to do instead was actually to focus on building reusable functions that actually they create test conditions and verify the result. And essentially it's in order to do that, as opposed to creating an entire test case, if you just create on small functions that just set up a condition and then pass or fail that condition, and then on top of that, then having a consistent design of that function that can cater for a range of different operating systems and different commands. It comes to the whole keyword-driven architecture sort of paradigm that people are quite familiar with. We want to provide a consistent front end, a consistent keyword, a consistent function to the user that then goes ahead and in the back is sort of agnostic of the operating system or the vendor or the topology that specific test function is actually being executed on. In order for that to happen, we need a consistent data structure to come from the operational commands on devices, which we'll touch on a little bit later, but that's been a big challenge for us in order to achieve this. But the reason we want to do it is because by having these segregated small functions that actually test something specific in the network, it gives the tester themselves some flexibility to pick and choose how they want to actually set up the test case. So if you've got essentially a library that ranges a whole bunch of different network functions, then no two testers test in the same way. So we want to still give the testers in our group the flexibility to be able to pick and choose the way they want to test. So having these functions and essentially a library of these testable functions that they can pick and choose and string together to then form an automated test case, that's the path we decided to go down. So then moving on from that, the biggest challenge, as I mentioned before, that we had is that we needed a standardized structured data from regardless of what was underlying. So right now there seems to be no real standardized structure from operational data itself. So for example, show OSPF neighbour detail is a very common operational command we use to verify the status of OSPF neighbour. And what you can see here is that exact command used on two separate vendors provides a completely different CLI output with no structure, and there's no structure to this that we can then use programmatically. And what our goal is to do is to use these keyword-driven architecture here is what you can see is verify OSPF neighbour interface state is full. That's a very specific test function and validation that we want to make. And we want that to be able to be used regardless of the network it's being operated on, it's being used on, the vendor that's underlying it. And what you can actually see there is two of the input arguments to those. So we have connection key and uplink 0. Within the test case, they are actually references back to our test case source of truth and the inventory that she talked about earlier. So essentially there's no hard coding whatsoever here, and we can, as long as we can change and swing the underlying infrastructure, the underlying inventory and the underlying source of truth, then this same command and this same test case, when they're all strung together, can be used on a whole range of networks and underlying infrastructure, and that's the goal here. But again, in order to achieve that goal, we need to have a consistent data structure from across the board. So for us, we needed to find a way that how do you present that CLI output from various forms of various vendors and networks and everything in a more uniform way across the board. So for us, we had to build an interface that transforms these CLI outputs from the various vendors into a common data structure, which is tough enough in and of itself. But then on top of that, it is a relatively well-known concept in network automation when you talk about sort of service modeling from a Yang point of view or configuration level sort of stuff, as well as it'd be well-known. But from actually the operational and the network status, the status of network elements, it seems to be relatively primitive still. So we've had to build our own little interface to achieve this. One of the biggest challenges is there's a large variety of commands that actually vendors themselves and obviously across vendors as well that they'll produce the output you require, and you need to sort of choose the one that's going to best suit yourself and best suit your needs. So the idea that we've sort of tried to lean on is that we need to select a command that's got all the relevant information that we need to pass to validate the test criteria, but it also needs to have that information needs to be available across all the vendors that we want to have in scope for our, and platforms that are in scope for the network, for the frameworks for to look after. And then on top of that, we also want to be relatively efficient. So we didn't want to choose commands that are going to provide us with a whole bunch of information and fill up the logs that isn't relatively necessary to the test case. So the same boat, we want to have all the information that's going to validate the test criteria, but also in the most efficient way possible. And like I said, it's a bit of a challenge, and we're still working to find a better solution to this every day. It's by no means perfect. So yeah, gosh. Oops, I keep clicking the keyboard. I might have to start again here. So yeah, I'll start from this one. If we can edit that last couple of seconds out. So moving on from modularity now that we've got that modular backbone built, how do you actually use that from a user front end? And that's where the structure of our test cases comes into play. So for us, the way that we've chosen to use a user front end is Robot Framework. And I'd say a lot of people are familiar with Robot Framework. Why do we choose it? So for us, Robot was the best fit for us at the time when we started this. Mainly, first things first, is keyword-driven architecture met those the modularity requirements that we tried to implement, and those principles for reusability. And on top of that, they sort of read like, the keywords read like an English sentence in Robot Framework, which makes our transition from writing test steps in a manual test document to writing them in a Robot Framework file relatively simple. It has very clear and inbuilt test case logging and captures, that very good visual representation for us, that was a big plus for us initially. And then on top of that, Robot also provides an XML output response of the test case as well. So that allows us to further process that information after the test run, and then do things like update some inbuilt systems and management systems that are recording the test progress of the project and things like that. So we can process the XML response version of the results and then update tools later on down the track. On top of that, one of the most important points we wanted to convey today is that we use Robot entirely as a front end. So Robot Framework has a whole lot of programmability functions that it can do in itself. So you can write for loops in it and do a whole bunch of different things, for example. But for us, we've tried to eliminate that completely from the Robot Framework test cases. Everything, it's simply a user front end for us, and all the complexity is hidden in the Python functions in the back end. So just a little quick touch on the transition, why the transition's a bit easy. So just as a bit of an example here, this is some test cases that Chi and I actually did only a couple of months ago on a layer 2 EVPN network in the lab. And as you can see, this was the manual test document that we translated into the automated test cases. So the first step there you can see is essentially just to verify the current on the leaf nodes in the redundancy group, and then in the robot test case, it's very much the same. Verify software version on device is the first steps in the robot test case as well. And this is important for us when we're trying to change a little bit of the culture in a team where it's historically manual or has always been manual testing, and we're trying to transition people into the automated way of doing things. This is an easy way to do it because you don't have to be 100% understand. You don't have to have a heap of experience in automation in order to be able to write an automated test case in that way. If you have the networking knowledge and the understanding of how you need to test it, and then the keywords already exist for you to actually do that testing, then all you need to do is string them together in the test cases with very minimal. You don't have to understand the Python, what's going on in Python in the background, but you can still actually string these keywords together and be able to sort of integrate slowly into the automated world this way. So it was a good sort of transition for us to do it that way. Again, just a quick touch on the logging. So this is some of the logging on the right-hand side there. The HTML logging is quite nice for us. Like you can see, and that's all inherent. We didn't have to build any of that ourselves, so that was a really big plus. And then obviously on the CLI, you can also see on the bottom 3 lines, the first output file is the XML, and that's the one we process for further reporting. And again, I just wanted to touch on this. This was a major thing, was hiding all the complexity in the back end and using Robot as nothing more than a user interface. Allows us down the track, like we say, at the time this was best fit for us when we first started 3 years ago, but there's new and exciting tools always being developed in the industry. So by having all the complexity in the back end, just using Robot as a front end, we have the ability that if something more fit for purpose down the track actually comes out, we have the ability to swap out the user front end basically with relatively minimal effort if something better and more fit for purpose comes forward down the track. So with that, I'll pass you back to Chi to talk about the last of our principles, which is reservation and scheduling.
Thank you, Nick. Reservation and scheduling, yes, they come hand in hand. It's an important principle that we've come to understand. For us, it's the way we can maximize the utilization of our resource. Together with reservation, the schedule in our test case, because we built the test case all the way from the topology all the way to the end is the releasing of the resource. With scheduling, it can maximize the utilization for our resource. But yeah, it is one of the biggest challenges that we have. We have implemented the code, so there's a few decisions that we had to make. So point out some of those here is firstly the type of reservation and the scope of the reservation. So the type being shared or exclusive, the infrastructure link will be shared, and the scope, whether it's device, port, or instances. So then last but not least, the reservation, the system could not see really at the moment. There's no way we could work out whether a reservation is active for manual testing. So that remains an obstacle for us at the moment. So until we implement reservation in full, the scheduling possibly does not come into play too much. So I think Nick is going to put it all together for the next slide.
Thanks, Chi. Just in a bit of a summary to wrap up on what we've tried to cover today. These are those design goals that we had initially to try and achieve. It was the implementation and the slightly different implementation of these basic automation principles specific to the network testing space that's allowed us to try and sort of answer and actually continue to answer, because we're by no means there yet. But to answer these questions and sort of get well on our way to actually implementing something that does deliver for us all of these questions. So just as an example, the ones about reusable code, how do you cater for different networks, different vendors, how do you accommodate different test topologies, the entirety of all of these principles and the way that they've been implemented for this space, from inventory source of truth all the way through to the modular keyword architecture, into that structure, the actual test case structure in Robot Framework. That combination of all of that is what allows us to answer all of those questions. You have the reservation and scheduling, for example, is the way that we're going to be able to, once it's fully implemented, to coexist in an environment between automation and manual. And then together with all of that, if we can manage to answer all of those first 5 or 6 questions, then we're well on our way to actually answering the last and the most important one, which is actually building a framework that has the ability to lower the cost of our test programs without jeopardising the quality at all, and where we're confident that the quality of what we're putting back out to our engineering groups and out into the operational network is of a high quality, because at the end of the day, that's the business we're in, is quality assurance and making sure that what we put out there is good and it's not going to take customers off the air. So, and with that, I'll pass you back to Chi to talk through our final challenge.
Thank you, Nick. So the cultural shift, this is most talked about actually. So it's not very new, but I'll touch in here as well. And that any company or industry, the change from manual to automation usually is a bit of a challenge. It involves the culture, the people, the processes supports the people, and the automation, and the expectation is to what do we expect the automation to deliver. So for us, we try to manage the small steps a little bit at a time and see 10, 20, 30% in that way. And so in the so in that, I think we will wrap it up for today. And thank you very much for joining us today. And I hope some of these are useful for you. I know we tried to download 3 years of work in 25 minutes. Some parts are being pushed too quickly, so please feel free to reach out. So thank you again, and enjoy the challenge. I hope you enjoy it as much as we do. It's rewarding.
Thanks, Chi.